during our video. So have a look at the exercise number 9. It says, if a to b equals 7 to 6, find the value of 3a plus 5b to 7b minus 5a. So what can we do? First of all, a to b equals 7 to 6. We can write it in fraction, like 7 over 6, okay? And now it says that we should find the ratio of 3a plus 5b to 7b minus 5a. So also this one, I can write it in fraction as 3a plus 5b over 7b minus 5a. What can I do now? I have the ratio of a to b, so I can divide by the denominator and the denominator. Have a look. 3a plus 5b over b divided by 7b minus 5a over b. Now I can continue like 3a over b plus 5b over b over 7b over b minus 5a over b. I divided by b to create the fraction a over b here. And as you can see, b over b gonna give me only 1. So if I continue, I'll have 3 times 7 over 6, because I know that a over b equals 7 over 6. So in this case, 3 times 7 over 6 plus 5 times 1 here, because b over b equals 1. 7 times 1 again, minus 5 times 7 over 6. And if I continue again, 3 times 7, 21 over 6, plus 5 over 7 minus 35 over 6. Okay? Then, if I keep continuing, it's going to be 21 plus 5 times 6 over 42 minus 35. Okay? I can simplify number 6 here, and I'm going to have 21 plus 30 over 7, right? And if I keep continuing, I'm going to have 51 over 7. So my ratio is going to be 51 to 7. Okay? This is our solution. Okay, now let's continue with a new topic, variation. The word variation is frequently used in all science, but in math variation is direct. We have it 2 times: direct variation and inverse variation. So if 2 quantities are related in such a way that if we increase the one quantity, this is going to increase the other quantity, or if we decrease one quantity, this means that the other quantity is going to be decreased too. This is called direct variation. Okay? And the sign that we can use to tell that 2 variations are in a direct variation is this example, y equals 2x. Y equals 2x. Let's take some value of x's. If x equals 1, then y is going to be 2, because 2 times 1, 2. If x equals 2, 2 times 2 equals 4. If x equals 3, 2 times 3, 6. You see? 1, 2, 3, and it's going to be increased to here. 2, 4, 6. So what is direct variation? If two quantities are related in such a way that increase in one quantity causes the increase of the other quantity, this is called direct variation. You see? Let's see an example. Let's see example number 2. If y varies directly as x, find A, the equation connected x and y. B, the constant of variation k and the relation between x and y when x equals 7 and y equals 6, and the value of y when x equals 21. How can I find it? So first of all, I know that y varies directly as x, so I can immediately write y equals kx. You see? Here. And now that I know that the equation that I'm looking for is y equals kx, I can find the values. For example, in point B, x equals 7 and y equals 6. Now I can find the k. So instead of y, I can put the value number 6 of the value of y, my epsilon, so it's just 6 equals 7k, because the value of x is 7. So k equals 6 over 7, right? Because we're going to divide by 7, so k equals 6 over 7. And another thing is the value of y. We have to find the value of y if x equals 21. We have the value of k now, so we have also the value of x that is 21, so we can easily find the value of y. So y equals 6 over 7 times 21 equals 18. Okay, I hope that everything is clear about direct variation. Let's go on with the inverse variation. If two quantities are related in such a way that when one quantity increases, the other one decreases, this is called inverse variation. And we can write it like this way. For example, if y varies inversely as x, we can write it this way. Y equals k over x. This is my equation. Okay? Let's see an example. For example, here. If y varies inversely as x and y equals 8 when x equals 4, find y when x equals 16. In this case, I know that y varies inversely as x, so I can immediately write y equals k over x. Okay? And now the exercise gives me the value of y and the value of x. So what does this mean? This means that I can find the k. So x times y equals k, because I can do the cross multiplication here, because it's y over 1. The cross multiplication will give me x times y equals k. Okay? So in this case, I have the value of x, I have the value of y, I can find the k. K equals x times y. The value of x is 4, the value of y is 8, so k equals 32. This is the value of k, but hold on. The exercise says that I should find the value of y when x equals 16. Now that I have found the k, I can find also the value of y when x equals 16. So I'm going to have equals 4, find the y when x equals 16. So I know that y varies inversely as x, so I can immediately write the equation y equals k over x, okay? And now that I have the value of y and x, I can find the value of k. So k equals x times 1, because I can do the cross multiplication here and I can find that the k equals x times y. So the value of x is 4, the value of y is 8, k equals 32 because 4 times 8, 32, okay? Now that I found the value of k, I can find the value of y when the x equals 16. Y equals 32 over 16 equals 2. Why? Because the value of k is 32 and the value of x is 16 given by the exercise, so the value of y when the x equals 16 is 2. It's the same thing even if I have a quadratic x. For example, if y varies inversely as quadratic x and y equals 16 when x equals 5, so find the x when y equals 100. Since y varies inversely as quadratic x, I can write the equation y equals k over quadratic x, okay? I have the value of y and also the value of x, so I can find the k. K equals quadratic x times y, so k equals 400 because x equals 5 to the power 225 times 16 equals 400. And now I have to find the value of x when y equals 100. So k equals 400, y equals 100. So I can tell that 400 equals 100 quadratic x, or quadratic x equals 400 over 100 equals 4. X equals plus minus 2 because this is quadratic x. So the value of x is plus minus 2. So to sum up, I'd like to write that so we have the variation as like direct and inverse variation. Be careful, this is y equals kx and this is y equals k over x. So be careful with direct and inverse variation. I'd like to solve for you one exercise number 1. So it says, if y varies directly as x, find the y, and y equals 8 when x equals 2, find first of all the equation. So what can I do? It said that y varies directly, you see, directly as x. So I can immediately write that y equals kx. So this is my equation. When y equals 8 and x equals 2. So I can find the k from here. Instead of y, I can put the number 8 equals k times 2. I can divide by 2 here, and I'll find that the k equals 4. Okay? And the point 3 says, find the x. So find the x. I can write here. It says, find the x when y equals 28. Now I know the value of k, I know that is 4. My equation says that y equals kx. Y equals 28, k equals 4, and x divided by 4, divided by 4, x equals 7. Okay? So the exercises on the page 56, take it as a homework. If you have any question, please email me.